I'm Vinay Kumar, faculty in photogrammetry and remote sensing department. Today I'm going to tell you about how spectroradiometer is going to collect the data, and whatever data you have seen in hyperspectral data, you have seen that they are working in 10 nanometer or 5 to 10 nanometer spectral resolution. Now how ground spectroradiometer will work, that I will tell you about that. I have two spectroradiometer with me right now. You can see the spectroradiometers. Now you can see I have two spectroradiometer here with me right now. This is made up of field spec. Okay, field spec spectroradiometer, which is having spectral channels ranging from 400 to 2500 nanometer with 1 nanometer spectral resolution. And this is spectroradiometer made up of Spectra Vista Corporation. Now in this instrument, this is ASD Spectro Radiometer, which is known as Analytical Spectral Device Spectroradiometer. Now it is having one optical fiber which is going to collect the data with one pistol. This pistol is having 5-degree field of view, and this is your barium sulfate plate. Okay. Now by using this pistol you can target the object and you can collect the reading of this white reference. Now this barium sulfate plate is used as white reference, which is going to give you the reading for E radiance, which is incidence energy. Now for you know about that reflectance is your radiance upon E radiance, or reflected energy upon incident energy. Now this barium sulfate plate is going to give you incident energy, and other features whatever you are going to collect will give you the radiance of that, and ratio of this will give you the reflectance. Now for collecting the data, this spectroradiometer is connected with this laptop. In this laptop, 3 softwares are there. 2 softwares are RS3 and high contrast RS3. If you are going to collect data in laboratory, then you can use RS3 software. Now this is telling me that spectrometer isn't ready. So what I have to do, I'll have to switch on the spectroradiometer. Now it is saying me that spectrometer isn't ready because spectroradiometer was switched off. Now I have switched it on. Now for collecting the information of this, you will have to target this pistol, and then you can take the reading of white reference in this display. You can see after clicking over this white reference, it will give you the reading of this white reference. Because of the calibration problem, this laptop is not giving proper reading. So I will show you in second spectroradiometer, then that how it can give you the data. For this you can see this is Spectro Vista Corporation spectroradiometer, which is in the range of also 400 to 2500 nanometer. Now for this you will have to connect with this spectroradiometer with a PDA, personal digital assistant. Now in this PDA, with this you will have to first switch it on, and you have to switch on this spectroradiometer. Now this black object is the battery of this spectroradiometer. Now first switch it on this spectroradiometer, and after connecting this cable you can go to start, and you can go to HR1024 PDA, because this spectroradiometer is HR1024 model. So you just select HR1024 PDA. Now you will have to go to device control and connect. Now this cable is connected with COM1. You just select COM1. Now it is connecting. Now in this settings you can select the scan time. You can increase or decrease. So time I have changed to 4 seconds, and lens 4 means in this case you have fiber optics with field of view 4 degree. So this lens 4 is selected here. So you just say OK. Now after that you can see that there are 3 things: reference, target and dark. Now reference is for collecting the information of white reference plate, which is your barium sulfate plate, and target is whatever object you are going to collect the reading, and dark is if instrument is kept for some time, you can collect without taking any reading. It will give some of the error or some of the noise, so you can select dark for that. But for collecting the information of reference, you just target this spectroradiometer. Now in this spectroradiometer you have one button for laser. Okay, you can target now. For this you have targeted the object and it start scanning when you select the reference. Now in this case you can see that here it start giving that it is collecting the data for reference. Now after that, for taking the reading of the feature, I have here some green leaves. Now you just target the green leaves and now it started giving the reading of this green leaves. Now there is a difference between these two spectroradiometer, because in this there are 3 range of channels. First is having 500 tour, and I will tell you in this 1 nanometer spectral resolution is there, and in this case first is of 3.5 nanometer, and then 6.5 nanometer, and then 6.5 nanometer. So 400 to 1000 nanometer it is having 3.5 nanometer, and after 1000 to around 1900 it is having 6.5 nanometer, and then after from 1914 till 1850 it is 9.5 nanometer, and 1850 nanometer to 2500 nanometer it is 6.5 nanometer. Now after collecting this spectral profiles, you can go to files, you can go to graph, and you can see the reflectance curve. Now you can see the reflectance curve in this PDA. This spectroradiometer is best when you are going to use it in ground, and it will give you more appropriate result. So in this case, in laboratory, because light is not proper, so it is giving you very error and noisy data. In this case, you can see that there are lots of noise in this spectral curve, because light is not proper, illumination is not proper. So this spectroradiometer is best when you are using it in ground or proper sunlight is there. So reflectance curve will be more proper and more appropriate when you are using at sunlight. Then after, you can go to files and you can save this spectral profile and you can give name to that. बस अब छोड़ दो, रख दो, ठीक से रखना, वैसे वैसे. I have given name as vegetation. You can save it. I have given name of this spectral profile vegetation and you can save this vegetation spectral profile. Now accordingly, for different features you can collect in the similar manner and you can transfer this data to your system and you can use it properly for your classification or for hyperspectral data analysis and all. Whatever spectral profiles you have collected using spectroradiometer, how you will use that in your NV software. So I will tell you about building spectral library in NV software. Now for that, what you have to do, you can open your NV software and then after you go to spectral and go to spectral libraries and go to spectral library builder. Now in step 2, what you can do, after that you will have to select the wavelengths from. Now there are 3 options coming: data file, ASCII file, first input spectrum. So whatever spectral data you have collected using this spectroradiometer, you can save it in ASCII file, and the ASD Spectro Radiometer is giving data in first input spectrum, and the data file means whatever spectra you have extracted from your satellite image, or you can say your hyperspectral image. So after that, in this case I am going to do for select first input spectrum, which is imported from ASD spectral file. After that, spectral library builder dialog appears, and then you go to import and import your ASD binary file, whatever file you have transferred from your spectroradiometer, and then you select all the spectral profiles. After that, after importing all the spectral profiles, you select all and plot. Then end member collection dialog appears. Now in this end member collection dialog appears, you can go to edit and plot the parameters. Now in this case, this plot parameters window will appear, and this is your spectral library, whatever data you have collected. Now you can see that from around 1400 nano, means around 1250 to 1450 nanometer, there is having noise, and around 1900, in the range of 1600 to 1700 to 1900 nanometer, you have some noise, and from 2250 to 2500 nanometer, this all are due to some atmospheric absorptions and all. Now after that, in plot parameters, you can edit the plot title, you can give some name, you can change the background and foreground color, you can change the font size and character size. you can give the name of x-axis and y-axis. You know that spectral profile means uh, x-axis is having wavelength and y-axis is having reflectance. You can change all this thickness of axis. And now what you have to do, why I have written that change the tick marks of y-axis as 0 to 1 and increase as 0 point increment as 0.1 or 0.2, because due to some noise the range is varying from 0 to around 700 or sometimes it is 800 to 1000. So you know that spectral reflectance is generally varying from 0 to 1. So I have given the range from 0 to 1. After that, you can see this kind of spectral library is created, and for seeing the legend of that spectral library, you can go to options and plot key. You can see the legends of all those spectral profiles, and after that you can go to edit data parameters for editing the colors, the name or thickness of spectral profiles, whatever spectral profile is visible here, and then you just apply it. You can give new name for all the spectral profiles and you can change the thickness of that spectral curve. After that you can save the spectral profile as spectral library or ASCII file format. Now in this output plots to spectral library window appears, and you can select all items and rename your x-axis, y-axis, and you can see the scale factor is around 1. Wavelength units are 1 nanometer because that is ranging from 400 to 2500 nanometer, and you can give the name of that spectral profiles, that is a spectral library of all the features you have collected. Now after that you can see the spectral profiles, the spectral library you have made by using following the same steps from spectral libraries, but here you will have to go to spectral library viewer, and after that, after selecting that spectral library input file, whatever name I have given, that is spectra, and then you will have to repeat step 5 to 9 to change the parameters of spectra, whatever steps I have shown in the other steps during building of that spectral library. And I already told to you that because of noise the reflectance values of some spectra are very high. Now this type of spectral library is final output, and these are of some spectral profiles I have collected using ASD Spectro Radiometer, water body, mango, maize, kendu and crop and jamun. And this generated spectral library can be used for classification of hyperspectral data. That is, I will tell you about 3 or 4 methods, that 2 or 3 methods. One is spectral angle mapper, and subpixel classification is your mixed tune matched filtering and linear spectral unmixing. So by using this spectral library you can classify hyperspectral data and you can get more appropriate and better result for classification of hyperspectral data. I'm going to answer your question that I have seen. You asked me that which classification methods of hyperspectral I told to you. Hyperspectral data classification method, first one is spectral angle mapper. This is actually using spectra whatever we have collected from ground. Now in this case what we are doing, basically we are taking the spectra of your image. You have seen that hyperspectral data is having 10 nanometer spectral resolution. Now the angle between the reference spectra and image spectra is going to give you, means shorter the angle, better will be the classification. So you will learn this in your further lectures, that what is spectral angle mapper classification. And I told you 2 subpixel classification techniques, those are mixed tune match filtering and linear spectral unmixing. So according to the shape of those spectral profiles, or you can say that dips and means undulations of that spectral profile, you can classify that if it is perfectly matching with that spectral profile, that image spectra and reference spectra, then that is classifying you, giving that classification of that hyperspectral data more properly. Now for how to do the classification of hyperspectral data, I will tell you in my practical exercise that how to classify using the spectral library and your hyperspectral data, that is your Hyperion data, that how can we classify that hyperspectral data. Now you have asked me what is the meaning of ASCII and ASD file format. Now ASD file format is your .asd file, that is your analytical spectral device. I told you that device name is ASD Spectro Radiometer. So .asd file is your you can say that raw spectral profile of your ASD Spectro Radiometer, and ASCII file format is your just your text file in which wavelength is there and even reflectance values are there in text file. Now you told me that you asked me that specify the equipments for field observation. So if you want better reflectance curves or better spectral reflectance curve, spectral reflectance or spectral profile, then you can use ASD Spectro Radiometer, because the spectral resolution is around 1 nanometer or around 3 nanometer, and it is giving you very good spectral profile of any object, and you can correlate with your hyperspectral data. So you can use ASD Spectro Radiometer, and SVC Spectro Radiometer is also good. Now for classifying hyperspectral data, you can use the Spectro Radiometer, which is basically ranging from 400 to 2500 nanometers. You have asked me about the cost of spectroradiometer Trimble. See, whatever spectroradiometer we have right now with me, that is of SVC Spectra Vista Corporation, and second is of FieldSpec. That FieldSpec spectroradiometer cost around 35 lakhs, and SVC is also of similar cost. So the range, spectral range is of around 400 to 2500 nanometer spectroradiometer cost around 30 to 35 lakhs, and for spectral range around 350 to 1050 nanometer, the cost of those spectroradiometers are lesser. It is around 5 to 10 lakhs. So for other companies they are different. Now you have asked me what are the limitations of spectroradiometer. Limitations, see, for classification, I already know that absorption feature means you have learnt about your spectral profiles, that absorption features, whatever absorptions are there in spectral profile is giving you more proper or more classification of some objects. Suppose you have minerals, okay, so for spectral profile of minerals, the absorptions of some kind of features or some mineral features, you will learn that in spectral profiles, that for different minerals the absorption parts are different. So due to that it is classifying the data more properly. But now limitations, see, hyperspectral data you have seen, you have to do atmospheric correction, or you will have to do all the pre-processing first to classify it more properly and more accurately. So till now limitation kind of thing I can't say it, means I can't give it exact answer, but limitation means this is giving you spectral profile without any atmospheric attenuation or without any atmospheric disturbances, whatever you are getting by your hyperspectral sensors. So this is more appropriate spectral profile and better in comparative to your hyperspectral data. See, till now we are using hyperspectral sensor which is freely available in the internet, that is your Hyperion. That can be freely downloadable from Globis website. Hyperion data is freely available. Even if you will request, they can download, they can acquire for you, and you can use it for your purpose. And now for Indian soil, see, hyperspectral sensor in spaceborne case, Hyperion data is having very high spatial resolution comparative to other hyperspectral sensors. In IMS1 high C data is there, but the spatial resolution is lower, and even spectral resolution is around 64 bands. But in case of Hyperion data, that is having around 220 spectral bands with spatial resolution 30 meter. So you can use that data. Spectral curve of wet soil. See, for that I'll have to collect that spectral curve and then I can show it to you. I have whatever spectral profiles I have made for you for water and for other vegetation. You have seen in that spectral curve in my slide. So you can refer to that slide. And for wet soil, uh, that is having a signature lower than your urban features. See, urban features is having very high reflectance in comparative to wet soil. Uh, Now you can see the spectral profiles of some of the vegetation, some crops and water body. Now you can you know that for water body, the spectral profile, whenever it reaches to towards infrared, it gets absorbed. So you can see the water body spectral profile, and for other vegetation you can see that it is uh, from 700 to in near red to near infrared region, it is giving you your red edge. So spectral profile for vegetation, you can see it more clearly. But even if you have seen the spectral curve spectra of your hyperspectral data, you have seen lots of noise in that hyperspectral data. But in this case, without any atmospheric disturbances, the spectral curve from ranging from 400 to 2500 nanometer, except in some of the mid ranges, which is around 1350 to means near about 1500 nanometer, some noise are there. But before 2000, it's around 1850 to 1900 nanometer, there is having some noise, and near about 2500 nanometer you are having some noise. Now you have asked me that how we can verify the satellite data with the fieldwork data. Yes, we can verify. We can see that how the spectra we have collected. Suppose we have hyperspectral data. You know the latitude, longitude of that area. You know the position of that area. We have gone. We can go to field. We have GPS. We have spectroradiometer. Now we have identified the features that suppose some patches are there with vegetation. Now for that vegetation, we have collected the spectral profile, we have taken the GPS location. Now after that, we can come back, we can match the spectral profile of the spectral radiometer with the image, and we can see how it is perfectly matching with the hyperspectral data or not. And whatever hyperspectral data we have used, we will have to do proper atmospheric and geometric correction first, then we can match the spectroradiometer reading with that hyperspectral data. Yes, spectroradiometer is required for classification of hyperion data. I told to you that one most important method, spectral angle mapper. I am going to tell. I will demonstrate that practical in my practical exercise, that how to classify hyperspectral data using that spectral library we have created. Yes, because of atmospheric attenuation, atmospheric disturbances, and atmospheric absorption, this is the reason for the disturbances or noise in the hyperspectral curve. Somebody have asked me what we do in supervised classification of multispectral data taking training sets is not applicable for hyperion data. Yes, it is applicable, but there are some other methods also to classify hyperspectral data, and for that we need spectral library or spectral profiles of ground-based spectroradiometer. You can use same classification technique, supervised classification, like you can take training sets, training data, and you can classify your multispectral data. Means just similar to your multispectral data, you can classify your hyperspectral data also, but for better and accurate classification of hyperion data, you can use spectral profiles or spectral library or n members you have collected or you have extracted from your hyperspectral data, and then you can use that for classification. See, during atmospheric correction lecture, you will know that how to convert hyperspectral DN values data to radians. For that, in NV software, flash module is there. In that you will substitute. But one more thing, hyperspectral data whatever we are getting is in radians form itself. Okay, that is not DN. And during atmospheric correction, after atmospheric correction, that radiance we will convert to reflectance. You have asked me, is it freeware software? See, for open source software, I told to you that I don't know how to create spectral library in any free software. If I'll know, then I'll let you know. Because till now I haven't used any free software to create spectral library. I have only used NV software for creating spectral library, and even whatever spectral data I have pre-processed in View Spectro, that software is already by default with ASD Spectro Radiometer, so I have used that. So till now I haven't seen any free software to see the spectral profiles. And now we are going to wind up, so thank you.